Hello everyone, welcome back to computer graphics subject. So for today's topic is on the texture mapping. So let's find out what is the texture mapping and what is the topic outline for this topic. Here is the topic outline for today's topic. So at the end of the chapter, you should be able to understand what is texture mapping, what is MIP mapping, what is bump mapping, and what is environment mapping. Last time we were talking about shading and discuss what is shading, what is lighting. But basically color or the shading surface are not that realistic compared to the one that we have in real life. Okay, a real object should have a small surface features. Okay, at least it must have a small surface so that we can consider that object as a realistic surface. So basically there are two options in order to have a realistic graphics. Alright, so the first option is to use a huge number of polygons with appropriate surface coloring and reflectance characteristic. Okay, so in order to have a realistic surface or realistic object or polygon, we must use a huge number of polygon. But if we go for this option, there is a drawback because we will need to have a huge storage, okay, to save this number of polygon because we use a huge number of polygons. And another option is that we can use a mapping algorithm to modify the shading algorithm. Alright, so this option is the method or is the thing that we're gonna cover inside this topic, okay, which is about the texture or how we're gonna map the texture into a polygon. Okay, texture mapping. So let's find out into the introduction of texture mapping. Why do we need the textures? Okay, so why textures is so important, why we need to apply this into the polygon. Okay, let's see this effect of textures using this figure. Okay, I have this object. For the first one here is the model that we have. Okay, with just a model, it just show the wireframe. Okay, so this is the model with just a model. Okay, without shading, without texture. So this is how this model look like. Okay, so and then we go to the second stage, the model and shading. So what I like you to look into here is that at what point do things start looking real. Okay, for the first one is just a model, so it does not reflect the realness of the object yet. Okay, at what point? So just now from the model is not real yet. So let's go to the second stage when we apply the model with the shading. Okay, we apply the shading, so this is how it look like, the model with the shading. So at this point also the model with the shading does not reflect the realness yet. Okay, it does not look real yet. But when we apply the model with the shading plus with the texture, okay, imagine that this is the texture. Okay, this is the texture, and we apply this texture together with the models and then with the shading. So at this point the polygon or model is start looking real, okay, compare with just a model with the shading or the model itself. Okay, so that's why we need the texture, okay, so that we will have the model that looking real. What is texture mapping? Basically, texture mapping is just a method or process for defining a high frequency detail or using a surface texture or a color information on a computer generated graphic or 3D models. And this texture mapping will allow us to glue an image. Okay, this image is representing the texture of a brick wall to a polygon and to draw the entire wall as a single polygon. Okay, it allows us to glue a texture or image to a polygon. Okay, and it's allowed to render and map the texture image into the object. And to map an image onto a surface, such as there are several polygons or several objects that we can apply the texture mapping into. Okay, for example, we can apply a texture into a rectangles, a polygon, cylinder, sphere, or using a sweeping surface. Right, let's look into this figure. Okay, I have a sphere as my object. Okay, we have a sphere here, and This one is the texture that we have applied to this image or this object. Okay, this green texture here is just an image. Okay, we apply to this sphere so that it can wrap or glue this image onto this polygon or this sphere. Okay, that's this concept of the texture mapping. Why do people invented texture mapping? Because it is very difficult for a computer to generate a realistic texture, so they have developed a texture mapping method so that it can help us to have a realistic texture. Alright, so in which a photograph of a real texture is input into the computer and then mapped onto the object surface to create the texture for the object. Alright, so basically the texture can become from a real photograph, okay, come a photograph of the real texture from the real life, and then we can input this photograph or this real texture into a computer. Okay, we input this real texture into the computer, and then inside the computer it will map onto the object that we want it to be wrapped with this texture. Alright, and basically this texture pattern is defined by the m multiply n array of texels. Okay, what it is texel? Texel is the texture elements, right? If pixel is the graphic elements, but for texel is referred to the texture of the elements, right? The elements of the texture. If you look at these two figures, here is the real texture. Okay, this one is the real texture of the wood, and then we can apply this texture to the polygon or the object that we have. Okay, so we can wrap or using this kind of texture to our object so that we can have a realistic texture or realistic object, okay, to be used in the scene. For each pixel in the display for the texture mapping, it needs to be mapped the four corners of the pixel back to the object surface. And for curved surface, this 4 points will define a surface patch. Okay, so this is the first step of the texture mapping, where each pixel of the display will map the four corners of pixel back to the object surface. Okay, it will map the four corners of the pixel, and then it will map to the object surface. And then we map the surface patch onto the texture maps. And this mapping will compute the source area in the texture map. Okay, so for the second step, it's gonna map the surface patch onto the texture maps. Okay, from the surface patch onto the texture maps. And then the pixel values is modified by the width sum of the texel color. Alright, so the pixel value will be modified by weight sum of the value of the texel color. And by adding the specific pattern but the surface is still appears smooth, this process we known as texture mapping. Okay, whenever we apply or add the specific pattern to the surface or to the object, but the surface of that object is still appears smooth, we call this process as texture mapping. But whenever we add the characteristic or the patterns and then it have a roughness, for example, okay, it show the roughness surface, this process is known as bump mapping. Alright, so whenever the pattern is still appears smooth, is texture mapping, but whenever we add the roughness to the surface, this process is known as bump mapping. Okay, you can see two figures here. Why we need textures? Okay, the left figures is representing the scene without the textures, and the right figure here is representing the figure with the texture. So of course, the right figure with the textures is looking more real. Okay, looking more realistic and interesting compared to this one. Okay, because it have textures, it make the scene more interesting and realistic. By having a texture image, it will make our surface or our object look more lifelike. Okay, and in order to apply the texture mapping, first of all, what we need to have is that we need to have a textures first. Okay, so how to get the textures or how to make the textures? You can have the textures by just scanning it from the world. Okay, for example, you can scan the textures from the world. For example, if you want to have the textures of a cloud or a wood grain, for example. So you can just scan that textures, or you can paint them yourself as well. Okay, so you can either scan or you can make it or paint it yourself to be a textures. Okay, and once you have a textures with you, what we need to do next is that we need to store the texture in a 2D image. Alright, so we need to store that texture in a 2D image. And once we have that textures as a 2D image, we're gonna map that image onto the surface. Okay, we're gonna map that image onto the surface by a function which will map the u and v coordinate, okay, of our parametric surface onto the coordinate of x and y of the image. Alright, and when we're gonna apply the shading surface point, we need to look up the appropriate pixel from the 2D image, and then we're gonna use that to affect the final color, okay, based on the shading surface point. And then next one, you will have a favorite pictures painted onto a donut. For example, this figure, okay, you have this surface and then is gonna paint with the texture, so you have a nice donut like this. Okay, and this technique is called as a parametric texture mapping. Alright, here is some of the examples of the objects that have been applied the texture to it. Okay, here we have a brick wall here, okay, with the surface, and then basically this window is also a texture. Okay, this window also a texture that have been applied to this wall. Okay, and then this cylinder with this texture, and then this green cylinder here with the logo of it is a texture, and then this glass also have been applied the texture, and together with this globe. Okay, this sphere is just a plain sphere, but we have wrap it or apply the textures of this Google Map to it. Alright, and here also some of the graphic or the model that have been applied the texture to it, so you can see that it's look more nicer. Okay, with this texture applied to it, you can see that the scene will be more realistic and interesting to see. And here are the texture image that appear in the demo previously. Okay, you can see that this logo have been applied to that green cylinder. Okay, and then this texture have been applied to the glass. Okay, and then this texture also have been applied to the cylinder, and this wall. Okay, this texture have been applied to the wall, and then this window is basically a texture as well, have been mapped or have been glue it to this wall, okay, on the previous one. And then this texture image of the Google Earth here have been applied to the sphere to make it as a globe. In applying a texture mappings, firstly we need to conceive that a 2D texture image has a horizontal axis which has known as the U. Okay, for the horizontal axis is known as U, okay, based on this coordinate. This direction is a U, alright, and a vertical axis is V. Okay, this for vertical axis is V, okay, for both here. And then the bottom left corner of the image is at the origin 0 0. Okay, this one also 0 0, so this one is the both are texture. Alright, the 2D texture. What we need to understand is the horizontal axis is representing by U, and then for the vertical axis is representing by V. And no matter what size of a rectangle texture image are, the axes are scaled so that the top right corner is always at the coordinate of 1 and 1. Okay, no matter what size of this rectangle, okay, either this one or either this one. Okay, no matter how big or what the size of this rectangle, okay, it doesn't matter, but the axes are scaled so that the top right is always at 1 and 1. Okay, this one 1 and 1, this one also 1 and 1. Alright, for example, here is that we have this image of this brick wall. Okay, this is the image of the brick wall representing the texture. Okay, and then we have this rectangle here. Okay, we have rectangle, and then we have this brick wall as a texture, and the texture is representing by the U and V. Okay, and then this rectangle is representing by X and Y. So how we gonna map this entire image brick wall onto this rectangle? Okay, so basically this point or this surface gonna map with this coordinate at this rectangle. Okay, and then this 1 and 1 here, okay, this point gonna map with this point. Okay, and then this point gonna map with this point, and then this point gonna map with this point. Okay, this is how we gonna do a mapping on this entire image of brick wall onto this rectangle. Okay, either from this U to X, okay, and then this V to the Y. There are two terms exist when it's come to the texture mappings in computer graphics. First one is the magnification, and another one is the minification. Okay, so what is magnification and minification? Okay, here we have the texture here. Okay, a sky texture, and then just imagine that this is the pixels on the screen. Okay, this one is representing the number of pixels on the screen, and then this is the texture. So for magnification is basically is a texel that cover multiple pixels on the screen. Okay, as you know that texels is the texture element. Okay, so a texture element here will cover a multiple pixels on the screen. Okay, for example, they take this as a samples of the texels, okay, which is the texture element here. So from this it's gonna cover multiple pixels, okay, on the screen. Okay, just from this it can cover multiple pixels on the screen. So this is the concept of magnification, which is a texel or texture element will cover multiple pixels on the screen. While minification, okay, minification is referred to the process of having multiple texels cover only one pixels on the screen. Okay, for minification is using multiple texels. Okay, here we have multiple texels on this texture. Okay, a multiple texture element is gonna cover only one pixels on the screen. Okay, so this is the differences between what is magnification and minification. What is MIP mapping? Okay, so basically MIP is basically refer to many things in a small place. Okay, so MIP is many things in small place. So basically what is MIP mapping? MIP mapping is a process of pre-calculate how the texture should look at various distance, then use the appropriate texture at each distance. Okay, so this is the process of MIP mapping. Okay, is gonna base on how the texture should look at various distance. Okay, it has variety of distance, then it will use the appropriate texture at each distance. So that's mean that variety of distance together with the variety of texture. Okay, variety of texture element at each distance. Okay, and each MIP map based on this figure below represent the level of resolution. As you can see from this figure, there are many level of resolution or many level of texture, okay, based on how it should look like at various distance. By having a MIP mapping in OpenGL or in computer graphic, it can improve both quality and efficiency in displaying a texture surface. And a smaller texture image are generated from the original, and during the rendering process the image whose texel size is closest to the pixel size is chosen for the mapping, and this kind of process will generate the smaller image and choosing the image of the proper size during the rendering, and this process is basically automatically done in OpenGL. Okay, so why we have mapping? Because it's a kind of technique that can help us to improve the quality and also efficiency in displaying texture if surface based on the distance and also based on the pixel size and also texture size. Now we are talking about bump mapping. Okay, so based on this figure here, okay, which spot that bulge out and which one are indented? Okay, which one that stood out to you based on this figure? The answer is none, because this is just a flat image. Okay, this one is the flat image. Basically, the human visual system is hard to expect light from the above. Okay, it is hard for us to see this spot that have burst out based on this mapping, but in computer graphic we can perturb the normal vector without having to make any actual change to the shape. Okay, so let's see how this bump mapping. So basically the basic texture mapping we paint onto a smooth surface. Okay, we call this as a texture mapping. Okay, and then it will result in a smooth surface. So how do we want to make a surface that look rough? Okay, that have a roughness surface. So there are two options here to do this surface look rough. Option number one is we need to model the surface with many small polygons. Okay, we have to make the model with many small polygons. And option number two, we need to perturb the normal vector before the shading calculation. Okay, so if you look at this figure, this is how we make the surface look rough. And based on this ray of lighting or shading here, the real bump should have a ray like this. Okay, this is the fake bump and this is the fat plane. And if you look at this figure, you have a sphere together with the texture map. Okay, and then it's gonna add with this bump mapping so that we can have this sphere with a roughness surface. You can see there is a roughness surface on this sphere. Okay, can see on the skin of this surface. So generally we can say that bump mapping is a technique that can add more realism to synthetic image. It will compute more accurate shading for the embossment on the surface. If you can look into these two figures here, this is the ordinary texture mapping with no bump mapping have been applied to this cylinder. Okay, so the cylinder have been applied with this mapping, a normal mapping. And this is the one of the cylinder that have been applied with the mapping. Okay, and is add with the bump mapping as well, so you can see the roughness of this texture. Okay, so it provide us with more realism to this object. Now we are talking about environment mapping. What is environment mappings? Is basically is a specular reflection that mirror the environment. Okay, specular mean here is that the shiny surface. Okay, the shiny surface reflection that mirror the environment, and it will generate the environment that map either by scanning or by rendering the scene from the point of view of the object. Okay, if you can look at this object here. Okay, this is the environments maps. Okay, that you can see there is a texture of the environment, and then it's gonna map this into this object. Okay, so this object will look like it have a reflection, okay, that will mirror the environments. The other name or the other term of environments mapping is, we can call this as a reflection mapping. Alright, so this is a method for applying the environment reflection on a reflective surface. Instead of actually rendering the object that reflected on the reflective surface, we can prepare a texture that is panoramic view of the surroundings of the object, and then we can look up into the texture based on the texture coordinates. Okay, and environmental mapping may have nothing to do with the actual surrounding of the object, but this technique will generate a realistic appearance of a reflective surface and require much less time than ray tracing. Okay, if you can look at this example, is use a reflection mapping where is apply the environment reflection on the reflective surface. And here is the scene that have been applied several type of mapping. Okay, you can see from this figure there are a lot of objects inside here that have applied with the texture mapping, with the bump mapping, and also with the environmental mapping. Okay, so it's make this scene look nice and interesting to see for this scene and also environment of this. So what we have learned in this topic is that we have learned on the concept of texture mapping, and also we learned on the concept of MIP mapping and also bump mapping, and the last one we covered on the environment mapping. So that's all for today's topic. Thank you and have a nice day.